Yeah, so as Thomas mentioned, we decided to write one of our projects using the spec-driven development with AI in practice. And today I'll share a bit of the theory, how it works, the framework which I used, and actually show in practice some cases which I covered with this spec-driven development. So yeah. So this spec-driven development with AI is not actually a vibe coding. It's not a prompt and pray. It's just like a disciplined, repeatable workflow where Cloud Code becomes a reliable engineering partner. So most AI-assisted development right now looks like what people are calling the vibe coding. You describe something loosely, AI generates something, and then you iterate. It works great for demos and some side projects, MVPs, but the moment you are on the team, the moment the code base grows rapidly, the moment you are a lot of context in one session, it usually falls apart, and the AI has no memory, and your decisions sometimes disappeared or just ignored. So any autonomous AI coding agent runs into 4 fundamental limits. It has scope limits. It degrades as context expands. It hallucinates missing requirements. And it has knowledge gaps as it starts each session cold with no memory of past decision. And also it lacks a clear definition of done. Let's start with the problem, actually. So why does spec-driven development even need to exist? So we developers or other people started to use AI as code completion tool first. Then we used AI as a chat helper, like a smart search engine for writing the code. Then AI agent appeared, and we started to use prompts. But this one-way prompts returned wrong code and decisions in almost half of the requests. Then the plan mode appeared, and it becomes more predictable, as you can see what model knows and what should be added, etc. But the plan actually created for each run and prompt was deleted after execution, and the decision also disappears. So here's where spec-driven development becomes in handy. Yeah. So what's actually spec-driven development? In one sentence, it's write the specifications first, code second, and do it always. So spec-driven development means you define your goals, data models, acceptance criteria, and non-goals in a structured specification markdown file before a single line of code is written. So the specification becomes a shared source of truth for you, for your teammates, and for AI. And because each task has explicit acceptance criteria, done is an objective. It's a checkbox, not just a feeling which AI could have. So here is the contrast. Without specifications, the AI hallucinates. The requirements start from scratch every session and drifts from your original intent with no clear finish line. With spec-driven development, the specification is loaded at every session start. Decisions are recorded, tasks have acceptance criteria, and any agent, human or AI, can pick up where another left off. So architecture decisions live in the specification, not in someone's head. So here is this diagram shows actually the high-level flow, and in the center of it is, of course, the specification file. So you share your vision goals with the AI, create the specifications, then review. If it's ready, you begin to implement it, test it. If it's okay, you ship and just go to another feature. So these are feature specification template, how it could look like. So you just describe the problem, the success criteria, what is out of scope, what model changes and API changes should be done. And the test specification template, it's how this decision should be made. It includes implementation plan with steps, test plan, some definitions of done, etc. But this, how do you actually get started? So whether you are on a new project or an existing code base, so the paths are usually different. So On the new project, you should set up 4 things before writing any feature. It's Claude MD, if you're using Claude or whatever another AI. It's like the project constitution, the stack conventions, some band patterns, etc., etc. So Claude reads this at every session start. Architecture MD file defines your system design and prevents AI from proposing solutions that violates it. A specs folder with like one subfolder per feature, and probably a Claude folder with the commands which you could create by yourself. With existing code base, it's a bit more difficult because you can't specify like everything at once. So you should start by running some AI over the code base to generate an architecture description, use that as your architecture MD seed, then write the Claude MD file to capture gotchas already in the code. Then from this point forward, any new feature gets a specification first, and the existing code gets documented organically. So for existing large code bases, it's a more tricky part. But if you don't want to do everything by yourself, there is already a tool created or a framework. It's called Spec. It was developed by GitHub. It's the most popular one for now. So of course, there's some other libraries and frameworks like OpenSpec or Superpowers, etc., from other users. But I decided to use this one as it most powerful. So the flow for this, as I mentioned, it has like 5 steps. You set this constitution, like establishing the DNA and stack rules of the project. Then you specify your feature and clarifying it. Then this spec kit creates your plan on how it should be implemented, divided into the task, and then you implement. So in the feature level, it's also like 5 steps. Yeah, you describe the feature in the plain language, spec kit generate tasks, acceptance criteria, data models, and edge cases. It syncs command into Claude, and Claude reads all the specifications and executes tasks. And also it also updates the task status in the specification file and run all the auto linting, type check, and etc. So there is basically just few commands. So you start from this after installing this library. You start from a spec in constitution where you just describe your main principles. Then you write the specify. It's actually you describe in plain language, or you could prepare a file with if it's more if you need more description. Yeah, what will be built. Then I usually run this clarify command. It's when the AI basically asks you some questions which he didn't get from your description. Then you run plan to create the technical implementation. Then tasks divide into an actionable task list, and just implements it. So actually using spec-driven development, the mindset a little bit shifts. So as AI handles the syntax, and the fundamental bottleneck in software delivery is actually probably no longer the development speed. It's more a clarity of your plan, and you're not like a code writer anymore. You are an agent director. So a quality of your specification determines the quality of your output here. And also, I wanted to mention Figma MCP, as it is going to be a bit part of our next presentation. So it's also could be treated like a specification. So I used design server to include into my specification files. So it reads the design as a text specification, not just like screenshots. So in general, I could include the Figma link into the tasks. Then it's reading it and it's designed as specification, and then it just create pixel perfect component. So now let's go a bit to more practical way. So we started the project like mid-March. So we have like 3 different apps: web portal for the user, where he could select the location he needs to store storage. He could book it, log in with sweeps and etc. and book a storage. And then admin part, where the locations are created. We have units in each location. We have the customers list. We have products which actually join these units by size, and they could be sold to the user with different pricing and stuff. We of course have the chat for each unit, so the user could chat with the administrator, and in the chat there is possibility to ask for rating and stuff, and of course the orders and different linking. So in more practice way, I show you just a history of how one of the features was done. So I have this design to create a feature to add units for our system. So it should support like single unit, range, and bulk and import CSV, like 4 different ones. So I actually describe it to spec it by specify command. So it what I should get it from, describe all the inputs and stuff and different apps which I need to create. Then it creates some plan for it and begin after when then I run the clarifying command, which actually review what it has, and it sees that it has some missing gaps in the documentation, and it starts to ask me questions like what to do with third-party integration we have. And it's like gives you like usually few options, one recommended. I just select what it's recommend or not. Then it's few more questions about what he didn't understand. I could like select something and even write a comment or note about that how it should be done. In the end, we actually have all this files created, the requirements, what should be done, some API, what should be implemented, which data model we use to create this, the plan in different steps, which file should be modified, created, etc., like in steps, and some research where my decision are written. So if he has questions, I write some decision. It's got saved and used each during the implementation. So the general specification and the most interesting one, the tasks list. So for this feature, we have like 22 different tasks. And also as to remind about the Figma server. So usually I review this documentation and tasks, and I just add these links which design from Figma to use. So the model gonna have even more context and create like pixel perfect designs from scratch. So actually this component was created without even any my changes. So it was really good to test it with this one, because if for other features there should be some problems actually. If I forget something to specify and the AI didn't ask me, like for example, I forget to include pagination, and we were missing pagination for all of the tables, and I have to create another feature to add this pagination to each table. Also, I'm still like in testing this tool, and I still don't know what to do with some small bugs. So usually the other developers in internet, which I read, they trying to recreate the whole documentation and recreate the steps they do, like to cover those bugs. Some of them are just adding the bugs into the list of tasks. So I do the same. So if I found the bug, I try to fix it manually or using AI, and then just add this task to the list that it was fixed. So we are consistent. So having all the tasks in same place and all the specification. So I think it's really powerful because it's predictable. It's documented. And it's really fast development because I have all these 3 different apps. So backend, 2 front-end apps, the shared library. We have Swagger with all different APIs. We have the code coverage, for each particular models and stuff. So, and all of this was done like in a month and a half, a bit more, almost 2 months. So really powerful. So I think that's all from me. So if any questions, I'm happy to answer.